video. Hello everybody, and welcome to the 25th video on the channel. That is actually pretty crazy. We are zooming past these videos, and it's another geometry lesson. This is, I think, the third geometry lesson in this channel, and there will be some more to come. One big favor before I move on to the answers to previous questions, please make sure to like, subscribe, and turn on that notifications bell for more awesome content just like this. Without further ado, let's go into our answers to our previous question. For our first question, the answer is a right or right angle. Maybe I could write that if you feel a little confused, but right obtuse angle, right angle. And please make sure to go check out my last video for more awesome content just like this, and to know where these questions came from. Our second answer is a full turn or 360 degrees, where it rotates all the way around, thus making it 360 degrees or 0 degrees. Same thing, potato, potato, but I actually prefer to use 360 degrees when I'm saying it rotated all the way around, because even though it's the same as 0 degrees, the angle did change, so I just prefer to do it. But it's always your choice. And also, the math teachers will probably like it if you do full turn or 360 degrees instead of writing 0 degrees. For our third question, the answer is obtuse angle. This is where the angle is greater than 90 degrees. Of course, you can check out my last video and learn all of this stuff. So, that's it. Time to move on to the lesson. For today's lesson, it's pretty self-explanatory, or maybe it's not. I have a couple shapes before me, and if you're wondering where I got self-explanatory from, the title. It's just the title. But if not, if you didn't see that well, then I guess I'm going to tell you right now. This is about the areas of the shapes. The areas of different shapes, and these are the 4 most common areas that you will need to know. The first area I'd like to cover is this middle one, which I'm circling right now. This is the area of a rectangle, and the area of a rectangle, which is represented in capital A, is equal to the length, lowercase l, and times the width, lowercase w. Next we'll do the figure on the top right, the one which I circled just now, and the one which I'm actually going to circle in red, just so you know that this one is the one that it is. Alright, so this is the square. This is a square with side S, and the area, of course, still represented in capital A, is lowercase s, which is the s there, the side squared. For the one on the top left, the one which I'm putting in a rectangle, this, or a square, well, quadrilateral, same thing, but what I'm trying to say is this is half of the base times the height is equal to the capital A, which is the area. And the final figure, which is uncircled, is a circle, ironically. But this is showing the radius as r. The area is equal to pi, which is that 3.141 thing, variable or constant. You should probably know this by now. If not, there you go. Times r squared, where the radius is r. And that's it for the lesson. Time for the examples. For today, I actually only have 2 examples, and they're going to be pretty quick because I feel like you probably have learned this earlier, and I don't want to be like, oh, here's a big video explaining some preliminary concept, but I do want to make sure that I at least give you something. So I'm giving you these 2 examples, which I'm going to solve for you. In the later videos, I will have 3 and sometimes even 4 because they'll be more complicated topics. All right. Our first one is, as you can see, it's a circle with, instead of the radius, it's equal to 4. So if we do the formula, A is equal to 1. Nope, sorry, that was the wrong formula. Glad I caught myself. Area is equal to pi r squared. That is the area formula from above. Hopefully you remember. And then after that, we substitute r as 4. A is equal to pi times 4 squared. 4 is 16. So we have area is equal to 16 pi. Now, if you have a calculator or a graphing calculator, you could probably substitute pi as 3.141 and so on and get a more exact value, but this is all I'm going to show you. For our second example, this is a rectangle, so we're going to need to use the formula as A is equal to length times width. And oh, I accidentally switched this up. It should have been 3 here and 5 here. It would have been the same either way, but this side is shorter than this side. I mean, this side, the one which I circled here, is shorter than this side, which I'm circling here. The vertical side is shorter than the horizontal side, so I thought it would be weird if I made the shorter side 5 and the longer side 3. So I just decided to switch it up. And then length times width, this is the length, L is equal to 5, and then the width is equal to 3. So if we substitute this in, we get area is equal to 5 times 3, not 5.3, 5 times 3, and this is equal to 15. And one more thing I actually forgot to mention, it is good if you do units squared or if it specifies inches squared, because people can be very picky about that. And, well, that's really it for the examples. Of course, none of the videos is complete without me assigning you some practice problems. Today, I have 2 practice problems. Number 1, it's a square with the side of 6. And number 2, it's a right triangle with the base as 2 and the height also as 2. And for both of these, I want you to find the area. And if you want to use units, do units squared for your unit. Thank you so much. Bye-bye, and see you in the next one.